Welcome to the class of chemistry. In this class, I want to ask you something about, do you know how a chemical formula gets its number of atoms present in a compound? So when we come to the class 9th, we always hold one question in our mind, that how scientists or chemists know that this chemical compound owns the same formula, and how would they know that a particular compound will have a particular number of atoms. Let's start a video to answer this question. Let's answer a question that how scientists or chemists know the number of atoms of an element present in a compound. There are basically two types of bonds. I'm saying basically because there are other types of bonds also, but the two main basic types of bonds are ionic bonds and covalent bonds. In ionic bonds, there is transfer of electrons. That means one electron that has more number of electrons in its valence shell transfer it from itself to the another atom which has lesser number of electrons in its outermost shell to attain their noble gas configurations. So in ionic bond, the transfer of number of electrons decides the number of atoms of an element in a compound. As there is transfer of electrons from in ionic bond, so that is why ionic bond is also known as electrovalent bond. And the second type of bond is covalent bond. In covalent bond, there is sharing of electrons. So in covalent compounds, we use empirical formula method to find out the number of atoms present in a molecule. This empirical formula also give us the ratio of elements present in a compound. From this empirical formula, we can find out the number of the molecular formula of a compound. But in today's topic, we only cover electrovalent bond, that is ionic bond. In ionic or electrovalent bond, there is always a transfer of electron from one element to another, so that both can attain noble gas configuration. For example, sodium atom, that is Na, has an atomic number 11. So its electronic configuration is 2, 8 and 1. And another is chlorine, that is Cl, has atomic number 17 and electronic configuration is 287. So when sodium wants to attain the noble gas configuration, it has to lose its outermost this one electron, and chlorine needs to have one electron to add in its outermost electron to attain noble gas configuration. So what will happen? Let's take an example. Sodium has one electron and chlorine has 7 electrons in their outermost shell. This chlorine requires 1 electron. So sodium will lose its 1 electron to chlorine. Due to losing its 1 electron, sodium will attain +1 charge and chlorine will attain 1 minus charge. So both will combine to form NaCl, which is also known as sodium chloride. Let's take another example of aluminium chloride. Aluminium has atomic number 13, so its electronic configuration is 2, 8 and 3. And chlorine has atomic number 17 and electronic configuration 287. It means chlorine has 3 electrons to lose to attain noble gas configuration, and chlorine needs 1 electron to attain noble gas configuration. Let's take an example. Aluminium has given 1 electron to chlorine. Now aluminium is left with 2 electrons. Let's add 1 chlorine more. So this 1 more electron will transfer to chlorine. Similarly, 1 more chlorine we are using so that 1 more electron of aluminium is used. So aluminium has lost 3 electrons, so it will attain 3 plus charge, and chlorine will gain 1 electron, so it will attain -1 charge. So when we exchange the numbers, there will be -1 and there will be 3. So aluminium chloride's formula will be AlCl3. This formula represents that 1 atom of aluminium requires 3 atoms of aluminium to attain stable configuration. Here is the example that how aluminium uses its 3 electrons to stabilize chlorine atom. Thank you.